Hey everyone! So in today's video, we're going to continue Module 2. So we just wrapped up the sections from Chapter 3. Today, we're going to start the sections from Chapter 4, so 1 through 5. But first, I wanted to play you a song. So this is from Theodore Gray's The Elements. This is an app that you can download, but you have to pay for. So, if you don't want to pay for it, that's fine. But this is a really cool app. It shows you all of the different elements, and it has pictures of each, and you can see they're rotating, so you can see what they look like. And we are going to start getting into each of these elements. Now, some of them we might not quite talk about because they're a little more complex than what this class covers. But we'll definitely talk about the ones on the far left and the far right. And just to kind of give you a preview, you might have heard this song before.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.
All right, so I want all of you to memorize that song by the end of the quarter. No. Okay, so that's a little preview of what we're going to talk about. We're going to talk about atoms and elements. All right, so as you saw from that video, there are many different elements. In fact, there are 118 elements, and they've all been discovered finally, and that was actually really recent. So there are a lot of periodic tables out there, and even pretty recent ones aren't necessarily complete because it was just recently that we discovered all of the elements. So elements are pure substances. And that's what we learned about previously when we were talking about how to classify matter. And elements cannot be broken down into simpler substances. Now, your textbook does have elements listed on the inside of the front cover, but you can also find a periodic table of the elements on the course website under Modules, Study Guides. So it's titled Periodic Table. And again, that periodic table is not up to date, but it's a really good periodic table. It has all of the information you need. And again, we're not going to talk about all of the elements because for this class, we're more focused on kind of the elements to the far left and the far right. Now, elements have some interesting names, as you probably saw in that video. Some of the names come from planets, mythological figures, minerals, colors, geographic locations, and famous people. So, for instance, chlorine is named for its color, which is kind of a greenish yellow. So it actually comes from the Greek word for greenish yellow, which is chloros. Iodine is the same. It comes from, let's see, Ioides, I think it's pronounced in Greek. And that word means violet, and iodine does have a violet color. And then magnesium is named for magnesia. Tennessine is named for Tennessee. Curium is named after Marie and Pierre Curie, who did a lot of work with radioactive elements, and so on and so forth. So there are some elements where they were discovered by a particular group, and so that group got to name them. So there's all different sources for the names of elements. And you'll also notice that each element has a symbol. So chemical symbols, again, represent the names of the elements, and they consist of 1 to 2 letters, and they always start with a capital letter. Now, if there is a second letter, then that's going to be a lowercase letter. So, for example, off to the right, you can see a picture of carbon. And carbon has the symbol capital C. Nitrogen has the symbol capital N, fluorine capital F, oxygen capital O. But then there are some elements that also start with similar letters, so we needed a way to differentiate them. So for instance, cobalt, instead of having just a capital C, it's followed by a lowercase o. And then calcium also starts with a capital C, but is followed by a lowercase a. And then aluminum is Al, and magnesium is Mg. So I would like you to memorize the symbols and names of the first 3 rows of elements on the periodic table. Now, I have some online flashcards available. So if you look under modules, study guides, there are some flashcards for memorizing the names and symbols of the first 3 rows of the periodic table of elements. And the reason I want you to memorize those is it makes it so much easier when you're taking a quiz or a test to just know those symbols so that you know which element you're looking at. All right, so some symbols do make sense given the name of the element, and some don't. So it is a little tricky sometimes. So for instance, let's see, let's find a good one here. Lead. Lead's my favorite because the symbol is Pb, which does not make sense given the name of the element, but it comes from the Latin name of the element, which is plumbum. So that's always one of my favorites. Iron is similar, so Fe is the symbol for iron, which doesn't really make sense, unless you know that the original name of iron was ferrum. Mercury is another one. Mercury's symbol is Hg, which comes from its original name, I don't know how to pronounce that. If you know how, let me know. Potassium has the symbol K, which comes from its original name, kalium. And there's a few other examples here as well. So sodium is actually a really good one. Its original name is natrium, and its symbol is Na. And actually, there are countries that still refer to sodium as natrium, so its original name. Right, so the key point here is that sometimes the symbols don't match up with the name, which is why sometimes you just have to memorize them. Now, another key example is silver and gold. So silver has the symbol Ag, which is argentum, its original name. And then gold has the symbol AU from Aurum. Now, I used to get these two mixed up all the time, and I still do sometimes, to be honest. But I always thought that AG stood for gold because it has a G in it, right? But no, it's the opposite. So silver is AG, gold is AU. So sometimes it's easy to get the names and the symbols mixed up. Okay, so here's a learning check where you're going to write the correct chemical symbols for each of the following elements. So I encourage you to open up that periodic table document and search for these elements and then find their chemical symbols. And you can pause the video while you do that. Okay, so what is the symbol for iodine? I. So that one's easy. And then what did we say was the symbol for iron? Fe. So that's coming from its Latin name ferrum. What about the symbol for magnesium? That one's easy. It's Mg. That makes sense. What about zinc? Zn. And nitrogen. Capital N. So again, some of these are intuitive and pretty easy to remember, but then there's iron, which is Fe, which is kind of random. Well, I guess not really random. It has a reason, right? Seemingly random. All right, so that does bring us to the periodic table. So again, there are 118 elements on the periodic table, and the periodic table organizes the elements into groups. So each group of elements has similar properties, so physical or chemical properties, and they're all listed in order of increasing mass. So there is a reason why the periodic table looks the way it does. Now, this is not the only way to organize the elements. In fact, if you go to the Wikipedia page for the periodic table and kind of scroll to the bottom, it shows a few other examples of how other scientists have organized the elements. So some scientists have found really interesting ways to organize the elements into, for instance, spirals. So they kind of spiral the elements out, and then they have kind of chunks that are groups of elements. So like this would be an element, this would be an element, etc. So there's some really cool ways that people have come up with to reorganize the periodic table, but we're going to stick to the traditional version. So in the periodic table, elements are arranged according to their properties. So again, groups contain elements with similar properties, and those are in vertical columns. So if we were to draw kind of a rectangle as our periodic table, each column is a group. And then periods are horizontal rows of elements. So if we were to draw some rows here, we would call each of those a period. And there are actually 7 periods. So if we number from top to bottom, we would have periods 1 through 7. All right, so again, each column is a group, and those groups have similar properties. So for instance, you'll notice as we go from left to right, there's groups 1, 2, all the way up to 18. So there are 18 total groups. And then if we go from top to bottom and count the periods or the rows, there's 1 through 7. Now, one thing to note there are these two columns that are just, or two rows, I should say, that are just kind of hanging out by themselves. Those actually fit in right here. So they're supposed to be in the periodic table, but if we put those two rows in the periodic table, it would make the periodic table so wide that it wouldn't fit on a piece of paper. So instead, we've moved the two rows down into their own separate little area. So we have the lanthanides, which are supposed to be in row 6, and the actinides, which are supposed to be in row 7. And those are mostly radioactive elements or man-made elements, so we tend not to really focus on those in this class. So you can kind of ignore those for the most part. Now, you'll also notice that there's a second numbering scheme for the groups. You'll notice that we have 1A, 2A, and then it goes to 3B. And then when we go to the far right, we have 3A. So we'll talk about how to number the groups. There are two different systems in place. So group numbers are written at the top of each vertical column, as we saw. And we have two different types of elements. So if we go back, we have the representative elements, which includes the first 2 groups and the last 6 groups. And then we have the transition elements, which includes everything kind of in the middle here. Now, transition elements are kind of their own set of elements. They're very complex, and they don't really follow patterns, but the representative elements do follow nice patterns. So we tend to kind of separate out the representative elements from the transition elements. And this is also why we have two different numbering schemes. So for instance, we use the letter A for representative elements and the letter B for transition elements. Now this is also useful. Later on we'll find that the group numbers for the representative elements kind of match up with certain properties, so just keep that in mind. Now again, you could also number the groups from 1 to 18. That works too. But again, we're going to use the other system here because it's a lot simpler. All right. Okay, so in this class, we mostly focus on the representative elements. So we're going to really focus on the first 2 groups and the last 6 groups. And again, we can number those 1, 2, 13, 14, 15, etc. Or 1A, 2A, and then we'll jump over to 3A, 4A, etc. Now, we will talk a little bit about transition elements this quarter, but for the most part, we can ignore them. So you can just kind of ignore this middle section for now. Now, the first 2 groups and the last 2 groups have names for those elements. So you'll notice that the first group is referred to as the alkali metals. The second group is the alkaline earth metals. And then as we go to the very far right, we have the halogens in group 7A or 17, and the noble gases in group 8A or 18. All right, so group 1A, the alkali metals. So this includes lithium, sodium, potassium, rubidium, and cesium. Now, you might have noticed hydrogen is not listed here. So if we go back to this periodic table, in group 1, hydrogen is not considered an alkali metal. So hydrogen is actually a gas and has some different properties from metals. so we actually call it a nonmetal. But it does have enough similarities to the alkali metals that we often include it in group 1. So we'll talk about that later. All right, so the alkali metals specifically are highly reactive. They react with water very easily. They're also pretty shiny and gray, as you can see in the pictures here. So I actually wanted to show you a video of how reactive these are. So this is another app by Theodore Gray, and it shows different reactions of the elements. So I'm going to click on this video of sodium. Now it might be a little loud, so you might have to lower your volume.
Okay.
All right, so in that video you could see sodium being launched into a bucket of water, and then it exploded. And the same happens with potassium.
Okay? Yep.
All right, so you can see that was also very reactive and very explosive. And that's true for all of the alkali metals. Okay, so let's look at group 2, the alkaline earth metals. So in group 2A, or group 2, the alkaline earth metals are shiny, just like the group 1 metals, but they're not as reactive. So that includes beryllium, magnesium, calcium, strontium, barium, and radium. Now, one interesting thing is strontium is used in fireworks, and it gives off sort of a red color. Some other elements are included in here as well, like copper, which is a transition element, that gives off a blue color. Sodium in group 1 gives off a yellow color, etc. So a lot of elements are used for their beautiful colors. Now, group 7A, or 17, so we're going to the opposite side of the periodic table. These are the halogens. So this includes fluorine, chlorine, bromine, iodine. Sometimes you'll hear scientists say iodine because it follows the names of the other elements. You might hear me say it sometimes too. Also astatine, but astatine's a little bit different, so we tend not to really focus on it too much, but definitely fluorine, chlorine, bromine, and iodine. Now, chlorine is kind of a greenish yellow color, so remember its name comes from the Greek word chloros. Bromine is sort of an orangish red color, and iodine is sort of a purpley color. Additionally, chlorine is typically found as a gas, bromine is found as a liquid, and iodine is found as a solid. So even in the same group, we have different states of matter. However, they do have similar properties still, and that's going to have to do with their electrons. So we'll talk about that later on. Okay. Now, I actually wanted to show you iodine. So again, it's sort of a purpley solid color. So it's really cool to look at. But then additionally, bromine is sort of a orangish brown or red liquid. And chlorine is a greenish yellow gas. And sometimes it's hard to see. Okay. Now, the last group we're going to talk about are the noble gases in group 8A or 18. So the noble gases are not reactive at all. You really have to put in some energy for them to be reactive. So that means that they're highly stable. So this includes helium, neon, argon, krypton, and xenon. So, if you've ever seen a neon sign, that's a noble gas. You'll also notice that they each have different colors that they exhibit when you add energy to them. So helium's kind of a yellowy, pinky color, neon's sort of a pinkish orange, argon's purple, krypton's kind of a white blue, and so is xenon. All right. So let's do a quick learning check. Let's identify the element described by each of the following groups and periods. So you might need your periodic table for this one. So which element is in group 7A or group 17 and period 4? So let's actually go back to our periodic table. So we're going to go back a ways here. So group 7 is right here, group 7A, and we need to count down to period 4, so that's over here. So if we kind of draw some arrows here, that gives us bromine. All right. So now we can do the same for 2 and 3. Which element is in group 2A and period 3? So let's go back. All right, so group 2A and period 3, that gives us magnesium. And then the last one, group 5A, period 2. Okay, so group 5A, period 2. So we go over, and that gives us nitrogen. Now, it is really easy in problems like this to miss period 1, which has hydrogen and helium. So there's only 2 elements in that first row, but you still have to count it when you're counting the periods. That's an easy mistake to make. All right. So next time, we're going to talk about metals, nonmetals, and metalloids. But for now, just focus on learning the symbols and the names of the elements in the first 3 rows of the periodic table, and I will see you in the next video.